Hi, hello everyone. Hi to all my legends out there. I hope you all are still having the energy within you, right? Okay, if you don't have, get it somewhere because we are going to be having the class of alternating current for the next 1.5 hours, right? So try to show some energy and be there in the classroom with full of energy, right? So yes, this is Ameer, your physics educator at Unacademy. And क्या करना है? जल्दी से जल्दी give me a thumbs up and do let me know that I'm audible and visible to all my amazing legends in the classroom. And let me see how much of energy is already there in the classroom. Your warrior Miara is there to attack the legends. Oh my god. Legends, you got a threat. Okay, Miara is there to attack you. So I hope it is not going to be turning into a really big fight. Seems like I just want to remove your name as warriors and legends. Hi, sir. I think that your today's schedule was quite busy. You took. Yeah, there was. This is my fourth class for the day. Hi, Saloni. Hi, Sanoj. So, hi to everyone in the classroom. Hi to all my superstars in the classroom, right? So, yes, in today's session, we are going to be talking about the chapter alternating current, or which we use it with a pyara name AC. है ना? In today's class, we are going to be talking about some of the important concepts, a bit of, let's say, tough concepts in today's session, such as resonance, right? We'll also be talking about sharpness, right? And we'll also be talking about quality factor. And if we have time, we'll be talking about power factor. All these are very important. It is a bit conceptual. If you're ready, really ready to learn, I can teach you, right? If you're really ready to be there for the next 1.5 hours, we can learn this together. Are you all going to be there? Your awesome legend is here. Hi, Palak. Good to see you. Okay, I hope you all are going to be there, isn't it? Say yes or no. Jaldi se jaldi bata de. Jaldi bata, is it a yes or a no? Are you all going to be there or not? Yes, Miara. Very good. That's what I want. Yes. All the best of today's class. Thank you so much. Right? Yes, let's do it. Now, before we start with the session, like we do, let me give you some introduction. Hai. So today is the 9th September. Okay, which means here we are still with alternating current. We'll be having 2 more lectures for alternating current, and then we'll be having the Menti war. Okay, so try to learn all the concept before Menti war and try to be on top of the Menti wars list. Don't you think it is almost late, Hannah, to join and be a part of Unacademy? Because you know that only some months are left for your board exam, JEE or NEET, let's say. It's the high time for you all to join Unacademy, be a part of it, and so that you can enter into the college after your 12th standard wherever you want to, right? So if you want flat 10% of discount, if you while you make a subscription, don't forget to use a code. क्या AMB10, ठीक है और क्या? Now, amazing educators are there in this Unacademy class 11th and 12th YouTube platform. Okay, classes will be happening. If you want to get the updates of all the classes happening, come and join and be a part of this Telegram group. You can click on it and be a part of it. Okay, the link is given right there. Bugs Bounty, you all know what it is, right? It's an amazing way by which legends can get so much of prizes. How? You just have to go to the description, you will find a link, fill that particular link if you're finding any inappropriate content in any of the videos. Okay, if it is valid, prices aise aa jayega aapka ghar. Okay, that's an amazing offer, I think. And yes, Unacademy subscription, I'll talk about this for the next 2 minutes, then we'll start with the session, right? Those who haven't still joined Unacademy platform, I'll tell you why we all the teachers ask you to be a part of it. It's very simple, because there we all teachers will be teaching you with a proper schedule, right? And we'll be making with a proper target of board exam, JEE and the NEET exam, which means everything is going to be in super order and you can track every topic that is being covered in the classrooms, which means learning is going to be quite simple once you are on the platform. Then top educators of the country will be there, and more than that, you can maintain a friendship with them, you can talk with them, you can get some advices with them, right? It is going to be so much amazing. Then there will be doubt clearing sessions will be there, then study materials will be given, you don't have to look around roaming for books and from where to learn. Practice test and live test series will make you super confident and will bring out the best from every one of you, right? For all these amazing features, you should be going for the plus subscription. For 12 months, it will cost you 1,250, and for 24 months, it will cost you 1,042 per month. I know that you all will be asking for discount चाहिए. Discount चाहिए तो use कर ले code AMB10. You will be getting 10% of discount from the prices that is already being written there. Wow, that's amazing, है ना? और क्या sir, बिल्कुल. I know that so many students would love so much of features while you learn with Unacademy. For them, iconic subscription is the best because you'll be given a personal mentor to help you with all your study activities and academic activities. Live doubt solving classes will help you solve all your doubts when we teachers will be coming. Like this will be specially made for you. Then weekly report will help you improve and find your progress every week, and will also help you find out which are your weak topics, because understanding weak topic and improving is the best method of improving yourself. Okay, so this is all about an iconic subscription. For 12 months it will cost you 2,333, 24 months it will cost you 2,000 per month, and चाहिए तो discount चाहिए तो याद कर ले AMB10, okay, and put it as a referral code while you buy it. So jaldi ke jaldi, this is the high time. I am expecting every one of you to join and be a part of Unacademy as soon as possible. Okay, seems like the students are I can't see the energy in the classroom. It's a gift to us. Thank you so much. Let's crack it, intelligent mind. Wow, wow, Miara, from where are you getting all these lines, huh? Teach me also so that I can also use it in the classroom. Good evening, Sana, after a very long time to see. So if you all are ready, we can start with the classes. Where is the energy? Where is the energy that legends used to give me? This is my 4th class. If I'm still having this much of energy, my students should be having double of whatever I'm having. I think every one of you are super ready for the classes to get started, isn't it? So yes, let's go for it. So the main topic in yesterday's classroom, which we were discussing, was regarding the LCR circuit in series, which means inductor, capacitor and resistor in series connected across an alternating voltage. We have learned so much of things in yesterday's classes, Hannah. Do you remember? Right, yes. How to find out the total resistance, which we call it by the name of Z. Formula kya tha? Root of R square plus XL minus XC the whole square. What was XL? The inductive reactance. XC was capacitive reactance, right? This is the impedance, which is the total resistance of the circuit. Bus. And then we have found out how to find out the phase difference. Tan of phi, tan of phase difference, XL minus XC divided by R. है ना? Okay. Then what did we learn other than this? I think these are the main important things that you should be remembering from the part of Lcr circuit. Okay. If you do remember all these things, okay, the answer is gonna come ऐसे आ जाएगा. ठीक है? So yes, let's start reading the questions and let's solving the questions. Here we go. Okay, with a smile, let us start with our very first question. A circuit operating at 360 divided by 2 pi hertz. Frequency is given as 360 by 2 pi. Okay. Contains a 1 microfarad capacitor. So 1 into 10 power minus 6 farad is capacitance, and a resistance is 20 ohm. These are the given. How large an inductor must be added? L value in series to make the phase angle for the circuit as 0. What is the phase difference? Phi? 0. If it wants to be 0, what should be the value of L? That is the question. Okay? And the second part of the question is calculate the current in the circuit if the applied voltage is 120. Okay, we'll go to that later. First, let us find out kya karna hai. Haan, we have to find the value of L. For that, a small hint is given. Phi is 0. So start using from that particular hint. You know that tan phi is equal to XL minus XC by resistance, isn't it? Yes or no? हाँ sir, बिल्कुल. Phi value 0. Put it here. Tan 0 is 0. which simply says the numerator is 0, which is XL minus XC is 0. XL minus XC is equal to 0 from the previous equation, which simply says XL is equal to XC. What is XL formula? L omega. What is XC formula? 1 by C omega. मिल गया तो मिल गया, आंसर तो मिल गया. L is equal to 1 by C omega square. बस काम तो हो गया. Only this much to be done. Rest is calculation, mathematics, which you all are so good at, right? Start substituting C value. What is C value? 10 power minus 6. 10 power minus 6. And what was frequency value? That is equal to 360, right? Just making it yes. Frequency was 360 by 2 pi. Do we need frequency directly? No. We need the value for omega. Omega is equal to 2 pi f. That is 2 pi 360 by 2 pi. What do you have to do? 2 pi cancel kar le. We have 360. So omega is 360. Omega square is equal to 360 into 360. So this will be 10 power 6 by 360 square. And the value of L you can obtain is almost 7.7 Henry. Okay, ऐसे ही मिल जाएगा. इतना ही है. Very simple. Understood? Okay. If you go step by step by using all the concept, ऐसे ही आ जाएगा answer. You don't have to do anything other than this. Okay. Did anybody give me the answer before? Anybody? Okay, yes. So let us proceed further. I can't find any answers. We know the drill, hai na? You all know what you all have to do. Kya karna hai? Even before Ameer sir give the answer in the classroom, jaldi se jaldi you have to give the answer in the chat box. Okay, yes. So the second part of the question. Calculate the current in the circuit if the applied voltage is equal to 120. Array, current ka formula kitna hai? We'll be doing array. Space to nahi hai, kahan space? Okay, we'll do it here. Okay, we'll take a small space from here. Current is formula voltage divided by resistance, which we call it by the name of impedance here. है ना? ठीक है. Voltage is given as 120 divided by Z का formula root of R square plus XL minus XC the whole square. Here comes the magic. What is XL minus XC? How many of you do remember? What is XL minus XC? XL minus XC is equal to 0. We already have written in the previous page. So use it. User XL minus XC is 0. So this is 120 by R square plus 0 square R square. Root of R square ho jayega R. R ka value. What is R? R is equal to 20 ohm. Okay. So 120 by 20. This is equal to 6 with the unit of ampere. Okay, if you get the correct answer, if you understand the concept, मुस्कुरा ले ऐसा बस और कुछ नहीं करना. Okay, yes, is it done? Sir, I have full portion exam on physics on Saturday. Jaldi padh le. Okay, we are also learning here, and I hope you are also doing it from your end. Jaldi se padh le, and if you get an amazing mark, please let me know. Yes. So 6 ampere. Yes, many are giving me the answers. Nehal, Ria, Miara, Badia. Okay. One last question before we start with the today's concept. Ready है ना पूरा? मिल गया तो मिल गया, आंसर तो मिल गया, और क्या? बिल्कुल मिल गया. So the question. In the circuit diagram shown, XC capacitive reactance, XL inductive reactance and resistance is given. Question. Effective current through the source where V equal to 400. Array, this was a very simple question. Current was V by Z. Bas, if you know this much, the answer is in your hand. What is V? 400. Right? What is Z? That is equal to root of R square plus XL minus XC the whole square. Done. 400 by root of what was R square? R kitna hai? 100. So 100 square plus XL minus XC 200. minus 100, again 100 square. So this will be 400 by 100 root 2. इतना ये कर सकता है. This will be 0 0 cancel हो जाएगा. 4 by root 2. 4 by root 2 का उत्तर. 4 by root 2 का उत्तर जल्दी बता दे. This is 2 root 2 with the unit of ampere. Option is B. इतना आसानी से कहाँ से मिलेगा उत्तर? Okay, why are you getting all these answers so in such a simple fashion? Because we have learned every concept, right, and keep on holding to all those concepts what we have learned. Okay, now it's time for today's session. Yes, Mara, right, 2 by 100, 2 root 2 it is. 2 root 2 ampere. Yes, S, whoever that person has given the answer. 2 root 2, yes, yes. Good. Not 2 ampere, it is 2 root 2, Anna. Solving around 500 questions per day, Bharat. I can only give you that look. Such hai kya? If you're doing it, bahut badhiya. Okay. Okay. Now let us learn about new concept. Okay. So let us learn about today's concept. So here we go. Jaldi se jaldi. Resonance. How many of you have learned about resonance in 11th standard? Whoever have learned 11th standard should be knowing what is resonance. Hai? You should be learning what is called as resonance. Now, let us understand those who, I think some of you might have forgot the concept. Don't worry. I hope I'll give you a small example to help you remember what is resonance. Sabko yaad hai hanging bridge. I think everyone knows what is a hanging bridge. Aise, okay, let's say a bridge is hanging, which you usually might be seeing once you go for trips, and in so many places hanging bridges are there, right? What happens once this hanging bridge is there? You might have seen that, right? With that, when there is a wind, this hanging bridges will be oscillating like this, and it will be making small oscillations. Now, let me tell you that for every material which is undergoing an oscillation, which is undergoing an oscillation like this, will be having a frequency which we call it as natural frequency. What do you mean by natural frequency associated with a body? It's very simple, right? Natural frequency of a body is defined as that frequency with which it is comfortable to oscillate. Which means whenever you are trying to oscillate with the oscillate that particular bridge, okay, with the frequency of omega naught, it will be asani say it can do oscillate. Okay, that is what you mean by natural frequency. So if we try to oscillate this particular bridge with the natural frequency of omega naught, what will happen? This bridge will be oscillating with the maximum amplitude possible. And this phenomenon is what we call it as resonance. Which means if a system is made to oscillate with a frequency equal to its natural frequency, we call that process as what? We call that as resonance. Utna hi hai. And during the time of resonance, how will it be oscillating? It will be oscillating with the maximum amplitude. This is what you call amplitude. I hope everyone knows what is amplitude. Okay? So it will be oscillating with the maximum amplitude when the system is oscillated with a frequency equal to the natural frequency. This is simply defined as resonance. I hope sabko yaad aa gaya what is resonance. I was giving you a small example. Right? I think you all might have listened to many bad news related to this hanging bridges. Right? What are the bad news you might have learned? Listen, it is like the crash of hanging bridges might happen much of times. How? It is simply because the air which is oscillating this hanging bridges, okay, if it is trying to oscillate with this natural frequency, that bridge will start oscillating with the maximum frequency possible. If it makes huge oscillation, what will happen? That will be the cause for what? Breaking of that bridge. ये ऐसा होता रहता है. ठीक है? So this is the process of resonance. Now let's see how this process of resonance is so much important to an LCR circuit, right? How this concept of resonance is coming into this LCR circuit is what we are going to learn. Okay, let's do it together. Okay, so here we go. Now we are having an inductor, Okay, we are having a capacitor and a resistor in series connected across an alternating current. कर दिया पूरा? Everyone did this? And let's say the voltage you are applying is V0 sine omega t. Now the applied voltage is a V0. How will you get the maximum value for the current in the circuit? Right? What we are going to do right now, we are going to see, right, how the resonance is actually associated with the LCR circuit. Now, you know that whenever a voltage is there, a current will be there. How will you find out I naught, the maximum value for current? That is maximum voltage by resistance. Resistance of LCR circuit, क्या call करता है? Impedance we call it, right? Okay. V naught by, what is the value, what is the formula for Z? Z is equal to R square plus XL minus XC the whole square. This is the equation for current. Right? Now we are going to talk about resonance, right? Resonance is the process of oscillating with the maximum amplitude, which means we are going to see when is the current going to be having the maximum amplitude or the maximum value according to this equation. Okay? Let us understand. Now the current can be maximum, in which case if the denominator is lesser, right? If the denominator is having a minimum value, chotu value, so current will be so huge. For a given value of LCR, LCR is constant, right? How can you actually decrease the denominator? For that, let me rewrite this equation again. That is I naught is V naught by root of R square plus, what is XL? L omega. What is this XC? 1 by C omega the whole square. Now you look into the equation one more time and tell me how can you decrease the value of denominator? कैसे? देख ले, can you see omega? What is omega? The angular frequency which you provide, right? The angular frequency with which you are making this LCR to oscillate, isn't it? Yes. You can change the value for omega. You can keep on changing the value of omega so that the denominator will be having the minimum value. What is the minimum value possible for this particular combination if you keep on changing the value for omega? बिल्कुल, the minimum value possible for a square term is 0. So the minimum value possible is कितना होता है? 0 होता है. And if I keep on changing the value of omega and make L omega minus 1 by C omega as 0, if this term is made 0, you will be having I naught to be having the maximum value. What will be the maximum value of current in this case? That will be V naught divided by root of R square plus this. This is now 0. So, iska value kitna ho jayega? V naught by R. देख ले, which means if I keep on changing the value of omega at a particular value of omega, the current can have the maximum value. Maximum value is found to be V naught by R. Now the question exists is, what is the value of omega where you will get the maximum value of current? Let us rearrange this equation. L omega is, if 1 by C omega goes to right, 1 by C omega, है ना? We'll write the same equation on the next page. L omega is 1 by C omega. So rearrange kar le, omega square is equal to 1 by LC and omega is equal to 1 by root of LC, which means if you are providing an alternating current to an LCR circuit which is having an angular frequency omega naught of 1 by root LC, the current will be having its maximum value. What is the maximum value? That is V naught divided by R. How it is V naught by R? Because L omega by 1 by C omega is coming as 0 at this value of omega naught. So what do you call this omega naught as? This is called as what? This is called as resonance frequency. This is called as resonance frequency. Why resonance frequency? Because it is at this value of omega naught, the current's amplitude is having the maximum value. So we can call this as resonance frequency or natural frequency. समझ में आ गया? समझ में आ गया? So what is the natural frequency or resonance frequency of an LCR circuit? Omega naught is equal to 1 by root LC. Why do we call that as a natural frequency? Because in that particular case, the current will be oscillating with the maximum amplitude. What is the maximum value for the current at that time? V naught divided by R. समझ में आ गया? The main things that you have to keep in mind is these two equations. If you want to note it down, जल्दी से note कर ले. Okay, omega naught natural frequency or resonance frequency 1 by root LC. I naught max, it is equal to V naught by R. When the resonance is happening, the maximum value of current is observed as V naught by R. So these are the two things. समझ में आ गया मेरा? सबको समझ में आ गया? पूरा का पूरा legends लोग को in the class? जल्दी बता दे विद अ स्माइल. हाँ बिल्कुल सर, हमको अच्छे से समझ में आ गया. ओके, यस रिया, वेरी गुड. हर्ष, बढ़िया बात है, बिल्कुल बढ़िया बात है. ओके, प्लीज नोट ईच एंड एवरीथिंग डाउन, इट इज वेरी इंपॉर्टेंट. ओके, now let us proceed further and let us understand about the sharpness of resonance. What do you mean by sharpness of resonance, right? Now you understood that to this LCR circuit, right? To this LCR circuit, let us draw the LCR circuit again. Inductor, okay, capacitor and resistor, है ना? To this LCR circuit, once you provide a voltage which is V naught sine omega t, right, a current is produced, and the current will be having the maximum value. The current will be having the maximum value when the angular frequency is omega naught, which is equal to 1 by root LC, है ना? So if you plot a graph between omega naught and the maximum value for the current, here you have I naught value on the y-axis, here you have omega value on the x-axis. If you try to plot a graph, and if this point is found out as omega naught, you know that at this particular value, the current I naught will be having the maximum value I naught max. And for all the other angular frequencies, whether it is greater than that or lesser than that, what will be the value for current? Current will keep on decreasing. So this is how the graph will look like. Understood? Only at omega naught, the I naught will be having the maximum value. In all the other cases, I naught value will be chotu, 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 chotu. This is simply what I wanted to show you here. Understood? Okay. Now, you might be asking, sir, why we are using this concept of resonance? Where in LCR circuit is we are using this concept of resonance? I'll tell you. How many of you have done this? Okay, if you are having an old radio, okay, you might have tuned it, Hannah. You will keep on rotating that knob to different frequencies. Let's say you want to catch the channel of 91.9. So you'll keep on adjusting the knob to 91.9. At that particular time, that radio station is, we'll be listening to that radio, Hannah. We'll be listening to that radio station, isn't it? Okay, those who haven't done, if you go and talk to your grandparents or something, they'll be telling, okay, they're used to have all these kinds of old radios. Nowadays, I don't think anyone will be using this. You had, okay, you had done, Palak. Very good, very good. You have that type of radio, Anna. Very good. Okay, don't you want to understand what you're doing while you are rotating that knob actually? And you want to understand, Anna? Okay. That radio, okay, that radio is actually an LCR circuit. It will be having an antenna like this. So to this antenna, different radio channels will be coming. Let's say one of the radio channel is 91.9. Okay, these are frequencies. 91.9 is frequency. Another channel is 90 frequency. Another channel is 93.5 frequency. All the channels will be coming. Every frequency will be received by this antenna. But at a time, you don't want to listen to all the channels. Let's say you want to listen to only to one channel, 91.9. Okay, what will you do at that point of time? You will keep on rotating the knob. Okay, once you are rotating the knob, do you know what you're doing? This is an LCR circuit, which is your radio. Once you are rotating the knob, you are adjusting the value of L and C so that the frequency will be becoming 91.9 because you wanted to receive that particular channel. Okay, what you're doing while you're rotating the knob, you are adjusting the value of L and C so that omega naught or the frequency will be equal to the 91.9, the frequency of the channel. Once you adjust it to this particular frequency, what will happen? The frequency of the incoming signal, which is the source signal, will be equal to the natural frequency. What happens? The source frequency will be equal to the natural frequency at that point of time. The current produced by this particular channel will be having the maximum amplitude, I say. समझ में आ गया? The current produced by this particular channel's frequency will be having the maximum current. Then you will only be listening to only that particular channel. समझ में आ रहा है? Rest of the signals obviously will be received. 93.5, 90 frequency, everything will be received, but it will be oscillating with chotu oscillation, which you won't be listening to it actually properly. Understood? This is one of the main use of this concept of resonance of LCR. समझ में आ गया? सबको समझ में आ गया? Where we actually use this concept of a natural frequency. आ गया तो आ गया, समझ तो आ गया, हो जाएगा, है ना? Okay. So for this process to happen, है ना? For this particular process to happen, now listen to me very carefully. We are going to the new concept of sharpness of resonance. Okay. For this particular thing to happen, as I have already said, other frequency will also be absorbed by the antenna, but it will be having lesser amplitude or it will be producing lesser current, but still it will be there. Okay. One other channels are also playing and along with the main channel which you wanted, थोड़ा noise disturbance हो जाएगा, है ना? So you don't want the other channels to get absorbed, or even if the other channels are absorbed, the current value that it produces should be very low, which means that channel should be not interrupting. ठीक है? For that particular purpose, let's see what can be done to this LCR circuit. Question is, okay, what we can do to the LCR circuit so that we won't be taking all the other signals or all the other alternating current of the different frequencies other than the natural frequency. ठीक है? So कैसे? Now I hope you do remember this particular graph which we have drawn. The graph between I naught value and the omega naught value. So at omega naught, the current will be having its maximum value. So when the value of omega increases than this or decreases than this, the value of current will be lesser. Okay. Now you have to know that even though this, even though at omega naught you have the maximum value of current, right? Other frequency currents, look, can you see two other frequency here and here? Okay. Even though at these frequencies the value of the current is almost comparable to the maximum value of the current. Understood what I said? Omega naught is having a maximum value of current, but other frequencies are also having a very good amount of current produced in the circuit, which is almost comparable to the maximum value of current. So this will disturb our signal reception, है ना? You don't want this to happen. So how can you remove other channels from here? If I can turn this particular graph as like this, array, 1 minute, I will erase it. What was my question? What was my question? How can you avoid the other signals that is being received? क्या कर सकता है? You can change the graph like this. If you can turn the graph like this, we can say that we are increasing the sharpness of this particular graph. Now, if the sharpness is being increased, you can see that other than omega naught, this is omega naught. If you take any other frequency, the current value now became smaller. If the current from other channels are smaller, we won't be listening to that channels. है ना? So now if the graph is being more pointed, we say that if the sharpness of the graph is being increased, what happened? Yes, the quality of the signal reception has increased. What did I say? For the quality of signal reception to increase, we have to increase the sharpness of this particular graph. So my next question, I have told you we can make the graph as such. Okay, can I just give two pushes from both the sides so that the graph will be ऐसे, so it will be looking more sharp? Is it what I'm going to do? बिल्कुल नहीं. There should be some procedure for it, right? So let us understand that procedure to increase the sharpness of the graph. Let us take another fresh page and understand this. So everybody listen, I'm going to draw the same graph. Okay, the first graph whichever I have drawn. This is omega naught and this is I naught max. Okay, now this is it. Now we are trying to find out an equation which can represent the sharpness. Now for that particular purpose, I'm taking one current. Okay, let's say I just took some random current I. Some random current I took. For this current to produce, if you extend the graph, you can see that there are two different values of omega. Let's call it as omega 1 and omega 2, where you can have the same I naught value, समझ में आ रहा है? Looking into the graph, there are two omega values, let's say omega 1 and omega 2, right? Where you can have what? The same value of I naught. I hope you do all remember the value of I naught. Formula is V naught divided by root of R square plus L omega minus 1 by C omega. If the omega changes, current value changes. Okay, so here this I naught is having this value, particular value for omega 1 also, for omega 2 also. This is what I wanted to tell you. Okay, let's write. If you look into this equation, right, you can see that omega 1 and omega 2 looks exactly symmetrical, which means to omega naught, if you add delta omega, what will you get? You will get W1, understood? Omega naught is being omega naught, if you add delta omega to that, you will get omega 1. And how will you get it? Omega 2. Omega 2 kaise? From omega naught, you can subtract delta omega. Understood? Okay, because it was symmetrical, so adding and subtracting the same difference, you can get the value for omega 1 and omega 2. Which means what is the difference between omega 1 and omega 2? Which means what is the difference in length between them? If you subtract W naught plus delta omega minus of W naught minus delta omega, you will get 2 delta omega. Which means the difference between these two, omega 1 and omega 2, is delta omega. Now my question is very simple. How can we increase the sharpness of this particular graph? Sharpness means the graph has to look so pointed. If it has to look too pointed, this difference between 2 points, what is it? 2 delta omega. है ना? Isn't it should be lesser? Isn't it should be lesser? What should be lesser? What should be lesser? हाँ बिल्कुल, if you want the graph to be so much pointed, the difference between the 2 points which we have just found out as 2 delta omega should be lesser. So we can understand the sharpness is inversely proportional to delta omega. So if you want to have large sharpness, the distance between them should be lesser. So for finding out sharpness, for finding out an equation for sharpness, okay, what you have to find out, you must be having an equation for 2 delta omega, and that is what we are going to exactly do here. Okay, that is what we are going to exactly do here. I know that it is a little bit of a concepts, but we have to learn it, right? It will be so much better. Those who want to only solve simple question, you can just by heart the final equations, but these concepts are really necessary. Shall we continue? I hope you still have the energy. I hope you still all of you still have the energy, right? जल्दी से बोल दे, जल्दी से बोल दे. Okay, yes, yes, yes. Everyone is talking about Sunit's number of questions that he has done in the class. If he has done 500, let him do. कोई बात नहीं. Let him do. Okay. So yes, S is giving me the energy. Very good. Yes, Anna. Let's do it. Right. Okay. Go. Let's go for it. Now, this is the maximum value for current. How many of you do remember what was the maximum value of current possible at omega naught? At omega naught, what is the maximum value of current? V naught by R. The maximum value of current at resonance omega naught is V naught by R. So let me take some random point here, okay, where the current is I naught, and let's say this current I naught is equal to I naught max by root 2. Okay, I'm taking a random point in the graph where the current is equal to 1 by root 2 times the maximum. Okay, let's say this point is equal to I naught max by root 2. So if I substitute that in the equation, कितना हो जाएगा? I naught max by root 2 is equal to V naught divided by root of R square plus what will be the value for omega? Omega का value कितना हो जाएगा? So you can take for a current of I naught omega 1 also. For omega 1 also you'll get the value for current as I naught. For omega 2 also. So it is up to you. I am choosing for easiness of calculation omega 1. Omega 1 minus 1 by C omega 1 the whole square. बस इधर तक कोई गड़बड़ नहीं है ना? Okay. So I'm going to rewrite this particular equation in the next page. So in the next page, how much it is going to be? I naught max by root 2 is equal to V naught divided by root of R square plus L omega 1 minus 1 by C omega 1 the whole square. Okay, same equation. What was the value of I naught max? I naught max का value कितना था? जल्दी बता दे, जल्दी 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 जल्दी. हाँ, just now I have told you V naught by R. Okay, and 1 root 2 is already existing, is equal to V naught by root of R square plus L omega 1 minus 1 by C omega 1 the whole square. I'm writing it a bit fast, okay, because it is simple equations. V naught cancels, right? So you have root 2R is equal to with root, so you'll be inversing it and you'll square it. So how much is root 2R square करने पे? 2R square. If you remove this root, it will be R square plus L omega 1. How many of you do remember? Omega 1 was omega naught plus delta omega. So I'm going to substitute that. Okay. Omega 1 is omega naught plus delta omega minus 1 by C omega 1 is omega naught plus delta omega the whole square. Okay. 2R square minus R square is R square. Okay. Then L from the bracket I'm going to take omega naught. This become 1 plus delta omega by omega naught minus 1 by C omega naught 1 plus delta omega by omega naught. Simple calculations, right? Okay. Okay, what is remaining? So this was with a square, Anna. This was with a square. So what I'm going to do is I'm going to cancel the square from both the ends of the equations. Done. Okay, I think most of the part is done. Now I have to make a small substitution here. What is it? 1 by C omega naught. What is 1 by C omega naught? I hope you do all remember omega is equal to 1 by root LC, omega naught. So omega naught square is equal to 1 by LC. So once you take 1 omega down, 1 omega का down कर ले, 1 by C omega naught is equal to L omega naught. Okay. Understood? Okay. So 1 by C omega naught I am going to substitute as what? L omega naught. कर सकता है? और क्या सर? बिल्कुल बिल्कुल कर सकता है. तो कर ले. So okay. So that is equal to क्या हो जाएगा? R is equal to L omega naught 1 plus delta omega by omega naught minus L omega naught 1 plus delta omega by omega naught the whole inverse. Okay, it's okay. This derivation is not going to be asked, so I'll be doing it faster, right? So you don't have to actually give that much of importance for this. Okay, I know that you are also looking, sir, क्या कर रहा है ना? By using what binomial expansion, 1 plus delta omega by omega naught the whole power minus 1 is 1 minus delta omega by omega naught. Okay, so L omega naught, this L omega naught will get cancelled. The second term will get added up. So 2 times L omega naught delta omega by omega naught. This is equal to R. We were trying to make an equation for sharpness. है ना? Sharpness. Okay. So I'm going to make that same thing over here. So I'm going to rearrange omega naught. This omega naught, I'm taking it to left hand side by 2 delta omega. Can you see? 2 delta omega I have taken. What is remaining? L omega naught by R. So this is the inverse of 2 delta omega. This is the equation for sharpness, and a name is given for the measurement of sharpness of the graph. We call it by the name of quality factor. So quality factor का formula हो गया L omega naught by R. Okay, you can just it is totally fine to forget about all these things. Okay, it is totally fine, but do remember this particular equation. The quality factor is equal to L omega naught by R. Fine? Is it fine? Is it fine? Is it fine? Okay, so rest of the things, the derivation, it's not so important, but anyway it was given in the textbook of NCERT, so main kiya. That's all. Okay, so you just have to remember the equation for quality factor. I hope now you have understood this. Okay, yes, I know that you also will be wondering, okay, sir ne kya kiya idhar. Now you'll understand how easy it is to start solving the problems from this particular part. It is not so much difficult to solve the questions from this part. You'll understand. Okay, let's start solving the problems. Okay, in a series resonant Lcr circuit. I hope you all are ready, Anna. Done. Okay, you don't have to get scared because of all that big equation and the solution we have seen. I just only want you to remember this Q is equal to L omega naught by R, the quality factor equation. Okay, you are the best. Thank you. Now, in a series resonant Lcr circuit, resonant means it is in resonance. If it is in resonance, I hope you do all remember what XL is equal to XC. For resonance to happen, the inductive reactance should be equal to capacitive reactance. We already have discussed. The voltage across resistance is 100 volt. Voltage across resistance is 100 volt. Done. And resistance is equal to 1 kilo ohm, 1 into 10 power 3 ohms. Capacitance is also given. The resonant frequency is 200 radian per second. Question is, at resonance, the voltage across inductor. VL is the question. Kaise? How will I find out the voltage across the inductor? Simple. Voltage across the inductor is equal to current, which is going to be the same through all the L, C and R multiplied by the resistance across the inductor SL. Hai na? Okay. Now I'm going to make a small change here. I into, as it is in resonance, XL can be replaced as what? As this is in resonance, XL can be written as what? XL can be written as, sir, bilkul, XL can be written as XC. Because it is in resonance, XL value has to be equal to XC. Then only we call this as what? Then only we can call it as resonance. Or kya? XC you can easily find out. How? Because C is there, omega is also given. Right? XC is equal to 1 by C omega. Lekin current, अरे करंट तो नहीं दे दिया, अरे देख ले इतना सिंपल है, करंट तो दे दिया है, I is equal to voltage across a resistance by resistance, है ना? और क्या सर, this is 100 by 10 power 3, 0.1. बिल्कुल इतना आसान था. Okay, so just substitute that in the equation. Substitute this in the equation. So this is equal to voltage across the inductor is I into Xc. I का value 0.1. Xc is 1 by C omega. Xc, the capacitive reactance, okay, 1 by C omega. 0.1 into 1 divided by C is 2 into 10 power minus 6, and omega value is given as 200. Okay, how much you will get? Finally, you will be getting an answer of 250 volt. बस उतना ही है. Simple सा सीधा सा problem. 10 power 3 won't be there, Miara. Okay, only 250 will be existing. 10 power 3 is not there, just 250. Okay, a small calculation mistakes might be. Okay, good. Okay, L is 12.5 Henry, but it is not being asked. You can also find L value because omega is equal to 1 by root LC. So by using that particular equation, you can find the value of L also. It doesn't matter. है ना, सबको सब whatever is asked, you can ऐसे find कर सकते हैं आप लोगों को, है ना. और क्या सर, बिल्कुल बिल्कुल कर सकता है. तो नेक्स्ट क्वेश्चन के लिए रेडी है? रेडी, स्टडी. Your sister solved it for you. Okay. Okay. So small mistakes it might be. Okay, that's it. 0.03 Henry inductor, a 10 ohm resistor, and 2 microfarad capacitor are connected in series. So we have Lcr. Question: at what frequency will they resonate? Question: resonant frequency formula. अरे we by hearted the formula 1 by root LC. और क्या सर, बिल्कुल is equal to 1 divided by root of L कितना है, L inductor 0.03 or 3 into 10 power minus 2, and capacitor is how much, 2 microfarad, so 2 into 10 power minus 6. So this will be 1 by 3 2s are root 6, 10 power minus 2, 10 power minus 6 is 10 power minus 8. Taking out of the root is 10 power minus 4. It can go up as 10 power 4. This much. बस इतना ही है, omega naught. Okay. Next, what will be the phase angle at resonance? So this is a new kind of question which we haven't done before. है ना? कैसे कर सकता है? You know the formula tan phi. What is the tan phi equation? Tan of phi equal to XL minus XC by R. Tan phi का formula है XL minus XC by R. But while it is in resonance, you know that XL is equal to XC. है ना? You know that XL is equal to XC in which case? While they resonate. So once they are equal, XL minus XC will be equal to 0. So tan phi will be equal to 0. Tan phi 0 हो गया तो phi का वैल्यू कितना है? अरे जल्दी बता दे. हाँ, phi का वैल्यू हो जाएगा 0. बस इतना. Yes, S has given the answer. Yes, 10 raised to 4 by root 6. बस. How come root 6, right? This 3 into 10 power minus 2, and capacitance is 2 into 10 power minus 6. This 3 2s are 6. ऐसे आ जाएगा 6. Okay, so phi equal to 0 at resonance. If you want, you can by heart this. Okay. Yes. I hope that problem of root 6 is over. Done. Done. Next question. जल्दी बोल दे. हाँ सर, बिल्कुल रेडी है मैं. Okay, so yes, let's start doing. Okay, so a 500 microhenry inductor and 80 by pi square, pico is 10 power minus 12 capacitor and 628 ohm resistor are connected to form a series LCR. Okay. Calculate the resonant frequency. Omega naught 1 by root LC. This is 1 divided by root of L कितना है inductor 500 into 10 power minus 6, 500 microhenry दे दिया. Then capacitance is 80 by pi square into 80 by pi square into 10 power minus 12. बस ठीक है. And how will you do this? Root of pi square, okay, it is pi, it will go up. Done. 10 power minus 6 into 0, 0 is 10 power minus 4. 10 power minus 4 into 10 power minus 12 is 10 power minus 16. 10 power minus 16 ka root will be 10 power minus 8. It will go up 10 power 8. Then what is remaining? These zeros are gone. 80 into 5, 8 5s are 40, that is equal to 200. Right? Sorry, 8 5s are 40, 400, root 400 is equal to 20. Bus. Okay. This is what? Omega naught. Frequency is asked. So frequency is equal to omega by 2 pi. Okay. Kar le. Omega naught is equal to 10 power 8 into pi by 20. Okay. Divided by 2 times pi. Pi cancel. Then what do you have? 20 into 2 is 40. So you can take actually 100 into 10 power 6 divided by 40. So you know that 100 by 4 is equal to how much? 100 by 4 is equal to 25. And this zeros, let it cancel. So this will be, let me write it here, 25 into 10 power 5. Okay, or 2500. Then what is remaining? 10 power 3. So I'm going to write it as kilohertz. So the final answer can be 2500 kilohertz. Bus. Okay. So like I told you, that derivation is not so much important once you know all these equations, right? You just have found out the value. Next question is, what is the Q factor of the circuit at resonance? क्या करना है? Q factor कर सकता है. Q factor कैसे? L omega naught divided by R. बिल्कुल बिल्कुल बिल्कुल. L का वैल्यू कितना है? L का वैल्यू कितना है? 500 microhenry. 500 into 10 power minus 6. Then resistance is 628. And omega naught का वैल्यू किधर? Omega naught is 10 power 8. Pi is 3.14 by 20. Okay. Mathematics करने पे जी boom ba, if I take it from my head, it will be 12.5. Bus. Okay, this is going to be the answer. समझ पे आ गया इधर तक? Okay. So this I am going to give you as a homework. क्या करना है आप लोगों को? You just have to do it as homework. कर ले. Don't worry, we'll be discussing the same question in tomorrow's class. Okay, this will be the first question we'll be starting with in tomorrow's class. Okay. So I know that today was a bit more conceptual part. We have discussed lot many concepts, but try to extract the main equations whatever we have learned in today's session. Okay, we have learned so many equations, to try to extract all those equations, right? Because if you know the thoda concept we have learned and those equations, that is more than enough in doing all the problems. Just try to do the problem for this particular question, you'll get to know it. Okay. Okay, so try to do as many questions as possible after the class and try whether you have understood all the concepts or not. So tomorrow we'll be starting with our new topic, which is a power factor. Okay, all these next topics we'll be covering in tomorrow's class. Okay, yes, LC oscillations and transformers. So we are almost have completed the chapter. No worries. Two more classes or three more classes. Bus. Riak, sir, can you please tell me physics educator from an academy? Huh? I am one. If you want someone else, I have no idea. Uh, Leaving. So, okay, you want to do one more question? Okay, that homework question we'll be doing it in the class. What's it? Because I took a vaccination today, so I'm having a bit of fever. That's the same. सर को फीवर है थोड़ा थोड़ा फीवर आ गया बिकॉज आई टुक द वैक्सीनेशन टुडे कोई बात नहीं so we'll do it anyway कोई बात नहीं so here we go assign voltage of a peak value the voltage is given as 10 okay is applied to a series LCR circuit in which resistance capacitance and inductance have a value of 10 ohm 1 microfarad and 1 Henry, which means the LCR values are given. Find the peak voltage across the inductor at resonance. The question is, find the value of a peak voltage across the inductor VL. Kaise? At resonance case. You all know that the voltage across the inductor is equal to the current. Okay, the current passing through that into the L omega value, isn't it? Okay, I into its resistance. If you want to write it as different steps, we can do it. I into XL, isn't it? Okay, so how will you first find out the current? It is resonance. What is the equation for current at resonance? V naught by R. Because XL minus XC both are equal, they will cancel out. So V naught by R is the value for current. What is V naught? 10. What is resistance? Resistance kitna hai? Resistance kitna hai? It is also 10. Isn't it? It is a 10 ohm. So this is also 10. So 10 by 10, it is 1. XL is equal to L omega. So L value is given here. L value is 1 Henry. So 1 into omega. Omega is what? Omega is equal to 1 by root LC. है या नहीं? और क्या सर? बिल्कुल ओमेगा नॉट विच इज द एंगुलर फ्रीक्वेंसी. याद है ना सब लोगों को? हाँ सर बिल्कुल याद है. 1 by root of L into C. L is 1. C is how much? What is C? C का value 1 microfarad 10 power minus 6. Coming out of the root is 10 power minus 3. It will go up 10 power 3. So this will be 10 power 3. Okay. So the voltage across the inductor हो गया 10 power 3 volt. Bus. Okay. Now the second part, the quality factor of the circuit. What is the quality factor formula? L omega naught by resistance. We'll do it in the next page. Quality factor is L omega naught by resistance. है ना? Okay. Now tell me what was the value of L? 1. What was the value for resistance? 10. Omega naught value. Omega naught value देख ले. 10 power 3. 10 power 3 bus 10 power 3 by 10 is 10 square which is 100. So quality factor क्या B value मिल गया बस इतना ही है. Okay, हंस ले if you have understood. Very simple छोटू concept है ना. Okay, so I think I'll stop now. Okay, my body is not actually with me at this moment. Okay, थोड़ा fever आ गया है. That's all. Thank you so much Palak. Thank you so much. Got it? प्यारा बढ़िया बात है. Okay, बस okay. So thank you so much. Thank you so much. Okay, thank you so much Anna for your care. Shreya. Okay. So what we'll be doing, we'll be continuing in tomorrow's class. Those who haven't liked the session, okay, jaldi se like kar le and show some love towards physics and Ameer sir. And let me give you the last thing, which means if you are going to plan for plus an iconic subscription, which you must be as soon as possible, because you already know we are closing toward the exam times, है ना? So it'll be better if you come and be a part of Unacademy platform as soon as possible. If you're going for 12 months, there is an offer that before 13 September, if you're taking 4 months free, and if you're going for 24 months, again 6 months free is being given to you. And along with it, flat 10% also discount is there. Kya karna hai? Just use this code of AMBTech. Okay. Now, thank you so much. Thank you so much for being here and making the class awesome. Hannah. So yes, do like the session before you leave, and you can also subscribe so that you will get all the notifications from the channel. So thank you so much for once again. So we will all be seeing at tomorrow's class at 10 p.m. So bye everyone. Take care and a very amazing good night I'm wishing everyone in the classroom.